When I talk about theological topics, I often make analogies to physical science. This will include chemistry, physics, astronomy, geology, or biology. This bothers some people. For some people, it bothers them just because they aren't used to it. For others, it bothers them because I understand the science I'm referencing differently than they do. Still others are bothered because they honestly don't think that theology should work that way. In another place, I describe my allegorical use of mathematics in explaining theology. I have a term for my theological insights obtained that way: Pythagorean Christianity. I think I've reached a point where I need a name for the times I use science this way as well. It's too bad that Christian Science and experimental theology are taken. Something like the Standard Model of Religion might be a bit overly presumptuous. Then again, I like presumptuous titles. There are a lot of definitions for science out there. A lot of people think only of the physical sciences when the word science is invoked. I heard a friend of a friend joke once that as a student of political science, you could tell it wasn't really a science. Anything that has to call itself a science, they joked, wasn't actually a science. So subjects like biology, chemistry, physics, and geology are real sciences. Political science, computer science, environmental science, and library science aren't real sciences, though. That is an interesting theory. Theology doesn't have science in the name any more than biology does. So if we're considering real science versus fake science, does that put theology in the real science category? There's a term out there, positivism. Under positivism, the seeker of knowledge compares their newfound knowledge set against data collected in the world. Just feeling right is inadmissible to the inquiry regarding the truth or falsehood of a thought. I think that positivism goes a little too far, but that it's a good boundary to set on one side. I think that positivism should have a lower bound set that when two agree on their feelings, then it's taken between them as true. After all, we feel that the light reflecting off a particular apple is red. We don't verify that against anything else. What I do appreciate about positivism, though, is that nothing is off limits for questioning. I may be talking to a friend, and we may both feel that two yellow lights emit the same things, but if I propose that we try taking various colors into rooms illuminated by the two lights, we may find that some secondary means reveals that they are, in fact, different even when they feel the same. This kind of reasoning connects strongly with analytic philosophy, reductionism, and empiricism. Analytic philosophy encourages the researchers to carefully define their terms. Reductionism encourages the researchers to seek out fundamental laws or parts that undergird distinct systems. Empiricism encourages researchers to verify their experience or intuition externally whenever possible, and to whatever extent is possible. When a field of study gets labeled as a science, such as computer science or political science, usually this is used to indicate that the study of this field is giving in to the particulars of analytic philosophy, reductionism, and empiricism. There are limits to each of these, of course. Analytic philosophy is employed to more carefully define our terms. In a meme recently reviewed by Dr. Sabine Hassenfelder describes fundamental particles by inviting researchers to imagine a spinning ball, except there's no ball, and it isn't spinning. These kinds of contradictory analogies are at the heart of any area of deep study. Fundamental physical particles are understood by those that study them at the deepest levels to have zero volume, and yet, somehow, they have a property known as spin, which has a lot, but not everything, in common with the property of angular momentum when one spins a round magnet. So when a physicist describes spin, they start with the well-defined, well-understood, common experience qualities of angular momentum, and then explain the modifications to this understanding needed to properly understand spin. There comes a point in that process when explaining things needs to stop, though. When all the parties involved understand the terms the same, I think it's okay to stop. Two researchers can never be fully sure that they understand things the same way, and assuming that they do has led to confusion in all kinds of fields in all kinds of ways. Reductionism seeks to find common, underlying processes or components to explain observations. This is where the understanding of the atom came from. Chemists like John Dalton noticed there were particular ratios of chemicals that interacted with no leftovers. Outside those ratios, there would be leftovers of one chemical or the other. The explanation was that there was a discrete packet of each, and they reacted with each other on a one-to-one basis. This theory didn't just explain why one reaction needed particular ratios, it explained why all reactions need particular ratios. Reductionism can go off the rails, though. In the Standard Model, all the particles come in 3 generations, which hints that there may be some kind of underlying structure. However, it doesn't provide a lot of clues as to what that underlying structure is. So reductionism and empiricism sometimes work at odds with each other. Empiricism seeks to keep explanations grounded. A researcher could propose almost any solution to the 3 generations of elementary particles, and researchers have proposed a number of possible explanations. The way to select between the various options presented by researchers is to see which most closely correspond to observations. This is especially true when the observations are independent of the production of the explanation. This often gets labeled prediction, but that term can be confusing when a researcher checks ancient historical records to see if a prediction made in modern times is accurate. Colloquially, we most often apply predictions to things that are future, but the point of an empirical prediction is not in the order of prediction and fulfillment, but in their independence. For example, a researcher might believe that a particular volcano erupted on a particular date, but there are no surviving records from that time and date. So they may predict that another location hundreds of miles away on the same fault line as the volcano reported an increase in earthquakes before looking into the records of the area. After the record search, the increase in earthquakes is noted, and this supports the theory that this was the time of the eruption. It's less impressive if the researcher found the historical records first. Of course, this often works at odds with reductionism. When particle physicists first established the Standard Model, they did so by watching jagged lines in mist coming off radioactive materials. No one observed an electron, and even less a top quark that can't exist outside an atomic nucleus for very long. When these discoveries were being made, some researchers such as Murray Gell-Mann suggested that they were just mathematical tricks and not real microscopic objects. Questions about how much we can really believe in things we can't actually see and how much evidence we need or can accept for things we can't see are ongoing questions in the philosophy of science. That kind of question comes down to how much weight we should assign to empiricism and how much to reductionism. So there is a bit of tension between these 3 elements. Analytic philosophy combines with empiricism to ensure that we speak clearly about what we observe. Analytic philosophy combines with reductionism to allow us to speak about things we can't observe directly with the same specificity and clarity that we speak about things we interact with. Empiricism and reductionism combine to ensure that we can research new things without inventing unwarranted things. And so when you have these 3 things working in concert, that's what I consider as science. Sadly, different areas of theology have not fully embraced any of these 3 elements. While I find the work of Dr. Joshua Reginald Sijuwade fascinating in exploring the idea of God as a philosophical trope, it's definitely a case of letting reductionism limitlessly override empiricism. God as a trope certainly could do any of the things we typically think of as divine activity, but the observations which confirm this are not unique to this theory. In short, there is no sense in which I can pick predictions from Sijuwade's trope theory against the predictions of Pinnock's open theism to determine which is more consistent with our observations. Trope theory is a fascinating area of pure philosophy. It replaces substance and quality theories from Socrates and their developments. Some philosophers feel like tropes give a better explanation for the world than substance and quality. However, there's no test to demonstrate that. There's no prediction where one theory predicts something independent of knowing it that the other does not predict. There are times when one or the other will explain things in a way that makes it easier for people to understand. But that's a matter of our minds, not the reality of these theories or the objects they describe. There's another field where this is true: mathematics. The difference between Euclidean and hyperbolic geometry is the assumptions, or axioms, that the researcher starts with. Each has their uses. Neither is right, yet they have many areas of contradiction. The researcher doesn't prove which geometric theory is right by measuring triangles. The researcher simply proves which mathematical world they are really in. One could even create a number system that counts up to 12, then starts over at 1. It turns out that our clocks live in that mathematical world. That is often where my Pythagorean Christianity posts explore. Of the infinite theological worlds of interpretation we could inhabit, I try to see which ones seem to most closely align with the textual and moral evidence we have. Textual evidence isn't the only kind of evidence that we have for God, though. The books of inspiration are one set that God has given us. The book of nature is another text we can use to understand God better. One of the things that I've always found intriguing is that physical laws prefer to be written in mathematical terms, where moral laws seem to prefer to be written in poetry and metaphor. Despite that difference, there are still things that bear consideration. Those who understand Einstein's equations governing relativity the best can make predictions using those equations, and they happen as predicted. It is famously necessary for satellites that are part of the GPS system to adjust their clocks using an algorithm created from Einstein's equations. This has allowed us to create the GPS network. One of the things that I would like to explore more often is answers to the question, what kinds of things has our exploration of theology allowed us to build? By this, I don't mean church buildings or architecture or sculpture or paintings. I mean advances in our lives. How would our lives be different if we had chosen a different theological base to draw from? And is that good or bad? How can we apply reductionism, empiricism, and analytic philosophy to our exploration of theology and gain insights into our world? If you have a subject that you think deserves this kind of treatment, let me know. In the meantime, I'm going to create a category on my blog to start these thoughts called the Standard Model of Theology. The other thing this category will be used for is to explore some of my more direct analogies between theology and physics.